Okay, so this is problem 7, and I labeled it as a bonus problem because it's meant to be a little bit harder than the other problems in this set, but I still think it's really good practice tying in multiple concepts together. And so we have 3 L1 caches of equal capacity are characterized by these benchmarks, and we have a direct map and a fully associative cache, and we have hit times and miss rates, and the miss penalty, we say that it costs 20 cycles. And then we say a way predictor is bolted on to the FA, the fully associative cache, and it predicts one way and it looks there first. We have some conditions here. Part A is asking to compute the AMAT of the direct map and plane fully associative and which one wins. So we can just use the AMAT formula, and we can do for direct mapped first. And so our hit time is 1 cycle. I have the formula up here, you guys can look at that too, plus the miss rate is 0.20. And what is the miss penalty? We say a miss costs 20 cycles, so it's miss 20, and we get 5. And then we can do the same thing for fully associative, and we get 3 cycles plus 14% miss rate times the same miss penalty given, and we get 5.8. So let's compare and contrast. We say, well, 5 is less than 5.8, so direct map wins. Even though the fully associative has a lower miss rate, but the hit time is way worse, so that's why direct map still wins. All right, part B. So we have an average resolve time calculated here, and I've given you the calculation of how I got that. An average is A, we say, is the accuracy, so how often it's right, and then the cost if it's right, plus how often it's wrong times the cost it's wrong. So we're asked to write the AMAT underscore way predictor using the evaluated resolve time, and then evaluate it at accuracy equals 60%. So let's write down the resolve time. That's just A times 1 plus 1 minus A times 4. And I'm going to expand this out, and I get 4, and then this is minus 4A plus A, so that's minus 3A. And so this replaces the fully associative, because this is bolted onto the FA cache. It replaces its fixed 3 cycle hit time, but the miss rate is still 14%. So let's just plug it into AMAT. It replaces this hit time, and then we keep everything else the same. So we have our 4 minus 3A plus miss rate, so we still have 0.14 times miss penalty, still 20, and we can do this out, and we get 6.8 minus 3A. And so let's plug in A equals 60%, so that's just A equals 0.6, and we get 6.8 minus 3 times 0.6, and we should get 5. And this is exactly the direct map cache. So fully associative is direct map with the way predictor. And so, we just calculated a new AMAT with the way predictor. Part C is asking for a minimum accuracy that makes the way predicted fully associative beat the plane fully associative. So we can use our AMAT here, 6.8 minus 3A, and we're solving for A, but we want it to be less than what we got for the plane AMAT for the fully associative. So it needs to be less than 5.8 in order to beat the plane fully associative. and we can get A as less than 1/3 or 33%. Okay, and then part D is asking what makes it beat the direct map cache. So we're doing the same thing. Minus 3A has to be less than, this time we're using 5 for the direct map cache. And we get a much larger accuracy of A needs to be greater than 0.6. So 60%. At least a 60% accuracy before the fully associative cache is actually worth choosing over the direct map cache. Okay, part E. This part I would say is the hard part. We're saying that the predictor can never be correct on a true miss. The line, if it's in no way at all, every miss will pay this 4-cycle detection before going into memory. So say I use my way predictor, right? And we can, like, if we go through and we see that, wait, it's not in any of the ways, it takes 4 cycles to resolve and to realize that it's not in any of the ways. And then we have to go to our miss, so our 20-cycle penalty. So in total, if it's not in on a true miss, we pay a 24-cycle penalty, because 4 cycles to resolve the way predictor and then a 20-cycle penalty, right? And so we're rederiving the way predictor AMAT with this in mind, with true misses in mind. So we're saying that we want to split up the probability of a hit and a probability of a miss, because originally we did not do that. So when we have a hit, let's call M the probability of a miss, and then therefore the probability of a hit is 1 minus M. Okay. And so we can split it up by doing the probability of the hit times the cost of hit, so what it costs, plus the probability of a miss times cost of the miss. Okay? And so on a hit, the data is in the cache, and the only question is how long the way predictor takes to locate it, right? So we already have that right here. This is the 4 minus 3a. That's the average resolve time, right? So we have 1 minus m times 4 minus 3a plus the probability of a miss times the cost of a miss. Like I said, we already calculated that as if with the way predictor, it takes 4 cycles to resolve plus the 20-cycle penalty to actually get it from memory. So that's 24 cycles. Okay? And so what is the probability of a hit? Well, we have a miss rate of 14% for fully associative, so that would be 0.86 for that, times 4 minus 3a plus 0.14, this is straight from the table, times 24, and we get 6.8 minus 2.58a. So this is our new AMAT.